Welcome back to the channel. I'm actually not in my shop today. I'm down at the roundhouse working on this component for a steam locomotive that's under restoration. I did a video on making this bronze bushing for this power quadrant. Once installed in the locomotive, this control handle will control the flow of oil that's going into the firebox, since this is being converted from running on coal. I'm not 100% sure where this handle was acquired from, but where it came from, it also came with this short little stubby control shaft. Now, this particular shaft is too small for what we need on the American Freedom train, but it's going to have similar characteristics. It's got to be machined for the bushing, and it's going to have this square milled on the end of it. The new control rod is going to be roughly 5 feet long. It's going to be made out of this material here. This piece is actually about 6 feet long because we don't know exactly how long it's going to need to be. So what I need to do now is machine down the top of it so it will slide into the bushing and also have that square feature so the handle can fit on it. But none of my machines have the capacity to take this piece of material, so I'm down here at the roundhouse using the 20-inch American pacemaker. And this should be barely big enough for me to fit this in. I can't slide this piece of material in from the back of the headstock because of how close it is to the accompanying wall. So I have to kind of slide it in from the front, which is also presenting a challenge because I had to move the tailstock all the way to the right. And once it was there, I barely had enough room to kind of snake this into the spindle. But I got it in there. I want to use a proper turning tool here, at least what I think is a proper turning tool. So I've got a tool holder, spare tool holder that I can use. I'll pop this cut-off blade holder and we'll swap it with something else. Now there's a lot of work going on in the roundhouse today, so you might hear some background noise throughout this video, but that's just the nature of working in an active rail yard. First thing to do is to face off the end. This machine doesn't have a DRO, so I just measured off with a scale and set a witness mark here. And we'll start turning down the diameter. I'm going to start with a light pass at first, but this machine is so big and heavy, I can take 100,000 depth of cut, 200,000 total, without this thing even breaking a sweat. I think the largest depth of cut I've ever done on this thing is probably 250 thousandths, taking a ½ inch off of the diameter. That was just for fun, but this machine was able to do it without even trying. I'm not getting a great surface finish with this tool, so I'm going to try swapping it out with a different geometry insert. Well, still not a great finish. It's actually a little bit duller than the previous one, but I think I'm going to just keep going here. I'll end up polishing this with some emery paper. I think we'll just go with it for now. I'm going to take one more really shallow cut here, and then we'll do a test fit with the actual bushing. I think I'll go ahead and try the actual bushing. It's still a little bit of a tight fit, but I think I'll clean this up here with a file and some emery, and we'll be good to go. Need to leave a little bit of room there. This will get oiled on occasion, so not a bad idea to have a thousandths of free play in there. Yeah, I like this a lot better. At least it'll give a little bit of room for some lubrication. Even though it won't be necessary with the bushing, a little bit of lubrication is never a bad idea. Well, I need to get this thing out of the lathe now and into the other room where we have a milling machine that I can use to machine the square feature on the end of the rod. Well, this mill that we're going to use to machine the end of this rod is a bit of a Franken mill. It's got a Bridgeport head on it, but this base is a really heavy-duty base off of some larger mill setup. I can't remember. I think it's a Pratt & Whitney, but it is massive, and I think it is every bit the size that I'm going to need in order to set up the super spacer that we have. But the first thing I need to do is take this big old 8-inch Kurt vise off of the table, which is going to take some doing as well because it is heavy. We'll get this table cleaned off at least a little bit. It's covered in this dust. This was an area where some work was being done in restoration of some window shades for a Pullman passenger car. And like most large industrial shops, any horizontal surface becomes a table. And again, like a lot of industrial shops of this nature, everything is covered in a bit of dust and dirt, and this super spacer base is no different. We have I think it's a 12-inch super spacer, and I'm going to need to set it up in the vertical orientation, or is this the horizontal orientation, so that I can machine the end of that feed rod. So I'll get this base set up somehow, and then I'll probably need some help, but we'll figure out how to get the super spacer mounted to it. You know, the larger these tools get, the heavier they get. Surprise, surprise. And this super spacer is absolutely no different. We don't have a crane in this part of the shop. I could go get a forklift, but that sounds like a pain. We don't have an engine hoist in this building. I'd have to go to another building to get it. So I think me and my friend Rollin here will just muscle it up onto the table. We'll get it. We just need a little bit of leverage.
I really don't know. I need to get something else.
Well, or the engine hoist, but even that's hard to get in here.
I need to get something to put underneath it once I get it up in the air. I think that's what I needed. Yeah, I think I'm gonna need to have to put a bar in here
Yeah,
and lift it up with, because this thing's
Yeah.
gotta weigh 200 pounds.
yeah. Somebody get hurt.
Off camera, I went ahead and mounted the base on the table after cleaning it up a little bit more and got it indicated in. So Pete and I here are going to try to muscle this super spacer into place and get it up on its edge, although I think we might need a little bit of help.
There just happens to be a route there. Let's chuck it on the route.
Well, we've got this steel bar here, and I think if we tighten down the chuck on the super spacer, we should be able to lever this thing over so it'll be in the horizontal position, and then we'll worry about moving it over to the bracket.
Watch, it's not stable. These tight?
Yep. Ready? 1, 2, 3. Oh. Let's see if we can walk it up.
I don't know if you got enough angle there. Okay, one down. Sorry, semi.
Here. Hey, Zach! Please, sir, we need some help. Grab the end of that rod. We need to lift this thing up so it sits on there. It's heavy. 1, 2, 3.
It's not gonna sit.
There's a key. There's a key in the bottom of this thing.
Yeah.
Can you see it?
Yeah,
Wiggle it.
Right there.
Drop.
right there.
Pull it. Is it on?
Watch the camera behind you up your right shoulder.
Oh, hello.
It's probably angled wrong now.
Your face isn't in it, but it's fine.
Well, that's fine. I don't like my face in it because that'll ruin the...
What are you, shy?
Lose.
What a weenie won't show his
Yes.
face on the internet.
Camera shot.
Well, I have a face for radio and a voice for silent movies. Can we get to the super spacer thing on the back to change that out?
Yeah. Not easily, but it can be.
Thank you, Zachary.
All right.
With the super spacer now mounted in the bracket, or at least as much as it needs to be for this operation, next we need to pop out the 6-position spacer on the back and swap it for the 4-position spacer.
There you go. There, let me make sure that we're getting some video of this. Well, that's... Oh, okay. Uh-oh. Let me take this. I guess we don't need this rod in here anymore. But that was very convenient for that to be there. Okay, so there already is one in here. That's 6. Whereas it says 4 over here, so it's going to go this way. What kind?
Oh, it's like a news NEWS.
Yeah, it's a Yuasa, I think.
Well, it is now. Could use some grease, but it rotates. Now, it should click in somewhere, right?
Okay.
Well, it's about here, too, that we realized that we really want this thing spun around the other way. The lever is going to be on the back of the super spacer, and it probably makes a lot more sense to go ahead and spin this thing around 180 degrees.
All right, so, yeah, well, that's what I was saying. I thought you meant you wanted it this way. Find it.
I mean, if you're comfortable as is.
And this is the wrench you would use to...
So, well, evidently, it is balanced. Give me a lever long enough.
Yep.
You probably want to come back as far as you can this way, so you don't run out of travel.
Yeah, I don't think we will, but that's a good point. I think that's pretty good.
Feels solid.
Well, everything's turned around and tightened down, so I can go ahead and get the control rod mounted up into the chuck and start looking at milling these flats.
A little bit higher than...
Well, it shouldn't really rub on here.
It shouldn't rub on here, right, so... But this...
Well, the flats
is gonna
only
rub
get milled down a certain distance. Obviously, we don't want to mill them square all the way to the area that rides on the bushing. So, and I want to give it just a little bit of play. So there's some space between the handle and the top of the power quadrant. So I think what I want to do is use some marking fluid here and scribe a line so we can figure out just how far we need to go. Well, I just want to mark the length of the bushing here, and easiest way to do that is to just go ahead and use the bushing. So I'm sliding the power quadrant on here to where I'll be able to take a scribe and just scribe around the bushing. I couldn't find an actual scribe, so every tool's a hammer when it's the only thing that you got. So I've got a pair of dividers here that will suit the bill, at least for now.
Oh, so my question I sent you about this thing is, instead of using a taper pin, what if we just drilled it for a roll pin?
I was thinking the same thing.
Well, now I need to remove this drill chuck and get a collet and an end mill. This machine is so big that the only real way to get up to the drawbar is to climb on it. And it's a big machine, and it's nice for operations like this. We have a project coming up here before too long, It's going to require this big, I think it's a 14-inch rotary table, and it will fit nicely on this machine with probably room to spare. So having this big heavy table is certainly a nice to have, but you kind of need it in order to get to the top of the Bridgeport head, because there's just no other way to reach it.
Supposed to be like a no step sticker right there on that table.
It was a good end mill.
Close that door, will you?
It was a good end mill.
Shearing force on that's gonna mess up your setup.
I can't get this thing to not spin. Did I run out of threads again?
Well, not exactly sure what was wrong with that other collet, but it was a little bigger than the 3/4 inch that was stamped on it, because I could not get it to grab that end mill. But this one right here looks like it's doing pretty good.
Yes.
What was going on here?
I don't know. That collet is junk, and we can't use that drawbar over here. Oh, that'll fit.
Well, as much of an advantage it is to have such a big machine, to be able to have big tooling on it, the disadvantage is it takes a lot of work to actually move it. So I got to put in some effort here to raise this table up so that the spindle will actually reach the control rod.
If I thought you were young, I'd have you crank this handle instead of me.
You're younger than me, quite. What do we
Yeah.
have?
A little tight?
Well, I need to refresh my memory here on the diameter of this control rod, because this is actually a week later after machining this on the lathe. So I need to calculate now how much material I need to remove off of each side of the rod in order to get me the dimension of the square that I'm looking for. The first thing I'm going to do is touch off the end mill onto the top of the control rod here. I'm going to raise the table up some arbitrary number here, probably 25, 50 thousandths. I'm going to turn this 180 degrees, do the same thing, and take a measurement, see how much further I need to go.
53. I hope I hit record. Ouch.
Pardon?
I'll take a measurement here across the flats, and we'll calculate what needs to come off next, and I think I'm just going to dial in that full depth.
I'm actually cutting it a little bit shorter.
Well, unfortunately, I ended up losing a little bit of footage there, although it really wasn't all that exciting. Just took some additional facing passes here. And now I'm going to go ahead and finish off this current pass to the depth here. And we'll take this all around 4 sides, and we'll give the handle a trial fit. Here, I'll show you. We'll give the handle a bit of a trial fit here, and it's, I think, going on fine. It's a little bit snug, but I think a little bit of deburring and filing, and it'll be sliding on there with no problem.
Including our fellow YouTuber, My Little Mule, who hates to have his face on camera.
I'll put the power quadrant here back on, and we'll give the handle a fit. I think I want to round over the edges a little bit on those corners. I'll just do that with a file. I kind of wish I'd put this back in the lathe and round them over, but that's just going to be entirely too much work for just this small feature. But I do want to knock off the corners there a little bit just to make it a little bit more aesthetically pleasing. Now we do still need to drill a hole here in the end of this feature. There is a, originally there was a taper pin that went through this handle into the control rod. I believe this was going to be like a number 6 taper pin, but I think what makes more sense is just to use a regular 3/8 roll pin. They're a little bit more readily available. They hold just as well. And it doesn't require the use of a specialized taper, which we don't have, or a tapered reamer, which we don't have anyway. So I'm going to get this drill bit here lined up as best I can and just drill this hole out for a roll pin. Although this is going to take a little bit of work to make sure it's lined up. When the taper pin was originally drilled, like many of these machines of the era, it wasn't drilled straight. So I need to line this thing up a little bit off kilter, which is going to mean that this control rod is going to be indexed in one very specific orientation, but that's an installation problem. So instead of trying to plug braze up the old taper pin holes, I'm just going to rotate this around and line up this drill bit with the entrance and exit of the old taper pin holes and drill out a new hole. I'll start here with a center bit here just to spot this location. Also gives me another opportunity to double check that I've got this lined up right, I want to give this 3/8 drill the best chance it has in going straight. I'm going to go straight to the 3/8 inch drill bit here, and of course we'll use a little bit of anchor lube to help keep things cool. Well, I have a 3/8 roll pin here. We'll drive this through and we'll just give this a bit of a test fit. This will have to come back out so I can disassemble everything, but at least this will give me another double check. Got a nice little lead hammer here driving it home. Yeah, I think this will work. We'll go ahead and pop it out again and take it out of the chuck. Did I make it long enough is the question.
Nope. We're willing to start after that, I guess.
Well, I think that's going to do it for this week. That's as much as I'm going to get done here on the power quadrant. There is one other piece of machining that has to be done for this oil valve, and that presents a very interesting problem, I'll say. We'll call it a challenge, in which that the part that needs to get machined is not easily replaceable.
I don't know.
Well, here's a shot from underneath the cab of the locomotive. That control rod will find its way down from the top and attach to the top of this valve. Now there's some machining that has to go on with this valve that I'm going to wait for another video. It will be the shortest machining, but the most high-stress machining I think I've ever done. That's going to have to wait for another video. I appreciate you watching. If you're not a subscriber, hit that subscribe button. Thumbs up, comments are always welcome. Big thank you to those that support the channel through PayPal and Patreon. Thanks for watching. We'll see you on the next one.